This
Electronics Limited,
conference will
Bangalore.
now be recorded.
Okay.
Now I am working as a project engineer in Bharat Electronics Lab. It's like defense sector. Now we are like
Okay.
doing like FPGA boards actually. It's like Xilinx based FPGA based. So these products are
Okay.
like uh,
Mm.
secrecy based products. It's like encryptors actually, encryptors and decryptors, which is used in the
Okay.
military applications. So I
Okay.
just want to look what is the like custom layout. I don't know like brief like.
Mm.
So just that's why I joined like.
Mm.
Yeah, that's it.
Okay. Okay. Yeah. Thank you. Yeah. Tanisha, can you introduce yourself?
Sir?
Tanisha Gupta. No, no, not you. I am talking about Tanisha Gupta.
Sure.
Are
Okay,
you
okay.
there?
Hello, good evening, sir. Am I audible?
Yeah. You're audible,
Uh,
Tanisha.
my name is Tanisha Gupta. I have recently completed my graduation with the
Mm.
Electronics and Communication Engineering
Mm-hmm.
from Banastali Vidyapeeth, and
Mm-hmm.
I joined this course to
Mm-hmm.
have the
Mm-hmm.
knowledge of like all the uh, analog and how to like uh, build the analog layout of the like
Mm-hmm.
things.
Okay. Okay. Yeah. Okay. Thank you, Tanisha. Yeah. Abhishek, am I audible? Yeah. Hello, Abhishek. Am I audible? Okay. Let us start the demo session of layout. I think probably you have idea about what is CMOS technology, right? So complementary metal oxide semiconductor. I'll be going through what are the tools, CAD tools we'll be using to draw the layout. And let me go with the steps, okay? Uh, how you can start drawing the layout. And before that, what are the steps are there? We will start right now. Is it my screen is visible?
Yes, sir.
Okay. Basically, to start the training overview, uh, so basically this is a 6 months course. In the 2 months, usually we'll be talking about the basic courses. Okay, let me draw this. So this layout course, it is a 6 months course. So out of 6 months and the basic 2 months, we'll be starting with the basics. So basics like we'll be teaching you. So the digital prospective circuits, digital system design, like covering with the combinational circuit and sequential circuits. So we'll be talking about this digital design circuits, and then we will be teaching you one editor, that is GVM editor. We'll talk about this GVM editor. So after this, we'll be talking about a few scripting languages. We'll be teaching you for the backend layout engineer. So those are we'll start with some Linux commands, basic Linux commands, and then we'll be going through tool command language, scripting language. So we'll be going through. This is about the basic course. So this will go around 3 weeks or 4 weeks. Probably sometimes it will go 4 weeks, 3 weeks or 4 weeks. So after this, so we'll be moving into in basic course even they will covering the CMOS also, CMOS also. So once you cover with this basic course, so we'll be moving into the advanced layout part. Advanced layout. So where we'll be giving the brief idea about network theory. Network theory. So then we'll go to the layout part. Advanced layout part. So this will go 4 months. This will go 4 months. So this is what the syllabus we will be covering in the layout. So if you look at what are the tools we are using for layout part is the tools we are using custom compile from the synopsis. These tools are basically used to draw. I'm talking about the tool which is related to the advanced part of the layout, and probably they will be using other tools like Sigwin. They're used for scripting languages like tool command language, and then they'll use the Sigwin for Linux also. They're using the Sigwin. I'm not talking about that. I'm talking about what are the tools which we are using for the advanced part of the layout. So in the advanced part of the layout, we'll be using the custom compiler. Basically, this is used to draw the schematic, to capture the schematic. We'll be using this schematic capturing and pre-layout simulation, draw the layout. Draw the layout, we'll be using the custom compiler. And other tools which we are using for pre-simulation and post-simulation, PrimeView. PrimeView. So basically, these tools are used to do the pre-simulation. Pre-simulation and then post-simulation. And other tools which we are using is nothing but a IC validator. IC validator. So basically, this is using to do the physical verifications. Physical verification like to check the DRC rules, design rules checks. LVS check means layout versus schematic check. And then the tool which are using to do parasitic extraction is nothing but star RC. Star RC tool. This is used for parasitic extraction. So these are the tools. So we are working in the advanced part of the layout. Now let us understand that what is the role of the layout engineer. So why layout engineer coming to the VLSI? What is the role of the layout engineer? So basically, the layout engineer is used to design the analog integrated circuits. Layout is nothing but drawing the. This is a graphical. We are writing the graphical shape of the schematics. Graphical shapes of the schematics. Schematics. So we need a layout engineer. So let me talk about this diagram. If you look at this diagram, this is what the entire flow of layout. So we'll start from capturing the schematic and schematic to up to post layout simulation. Post layout simulation. So any idea or any idea or a design start from here. So we'll start from the schematic entry. So first, based upon the idea, suppose I want to design a analog circuit for amplification, amplifier. So we know that analog circuits are basically whatever the signals available in the uh, real-time world are in analog nature. Nowadays, if you see that many of analog domain signals are trying to push towards the digital, where digital circuits are very less prone to the error and then more efficient than the analog. Still, why we talking about analog is nothing but if you take any signal before converting, if you take any signal which is available in real time, all in analog nature. So without analog, it is not possible that to interact with any circuits. Whatever the signals you see, the voice signal or temperature variation, wind variation, all these physical quantities in the real times are in analog nature. So maybe when you are capturing the analog signal, when you are feeding into the analog to digital converter, the strength of the signal is not high. So we need to amplify that. We need to amplify. We should improve the strength of the signals. So where analog circuits are required. See, earlier, way back to 40 years. So where we used to work with the bipolar junction transistor, then field effect transistors are came up. Now we are widely talking about the MOS transistors like MOSFETs, metal oxide semiconductor field effect transistors like are basically two types like depletion type and then enhancement type of MOSFETs. Basically, these MOSFETs, the characteristics of this MOSFET is using for amplification of the signals. You can design the CMOS MOS-based operational amplifiers. Where operational amplifiers can be used for many applications like summing applications, adding application, integration. You do mathematical calculations, do inverting and non-inverting operations. These MOS-based transistors are help us to build a amplifier circuit. It will also help us to build switching operations like switch on and switch off. Okay. So particularly in this analog layout, suppose I want to design a PLL which work at 2.4 gigahertz. If you look at the PLL block, there is many sub blocks are required. The blocks like phase detector, block like charge pump, block like a voltage control oscillator, like a block like a frequency divider circuits. Okay, so in this course, we'll take an idea. Based upon the idea, we'll start creating the schematic. So this is the first level. So you'll be start creating the schematic. Once you're creating any schematic, we need to verify this schematic before drawing the layout to this. Suppose you take an example of CMOS, complementary metal oxide semiconductor. It is a combination of PMOS and the NMOS. If I draw the schematic to this PMOS, CMOS, this is my symbol of PMOS, and this is a symbol of NMOS. And we know that this is a transistor of three terminal I'm representing here. So this is a gate, this is a source, this is a drain. Again, in the NMOS, this is a PMOS circuit, and this is a NMOS circuit. This is gate, this is drain, and this is nothing but source. And if I draw the VDD and VSS file, this is my VDD file, and this is nothing but VSS file, and then gate and gate will be shorting, and we will be having a demarcation line. So above the demarcation line, we call it as a pull-up network. Below the demarcation line is nothing but pull-down network, where gate and gate is shorted. This is connecting to the input, and then drain and drain is shorted. This is connecting to the output, V out. So this is a schematic of what? CMOS inverter. I call this a complementary metal oxide semiconductor, combination of PMOS and the NMOS. This what? To design any analog related ICs, first we'll start with an idea. Based upon idea, we'll draw the schematic. Once you draw this schematic, we should understand that how this schematic is working. So this is CMOS inverter. The inverter operation is nothing but if I give the input as logic 1, it gives me the output as logic 0. So if I'm giving any pulse like this, output should complement of this, complement of this. So this is a step, so we call it as a pre-simulation. So first you capture with the schematic. Once you capture the schematic, do the pre-simulation. Once you do this pre-simulation, then we'll be drawing the stick diagram to this. Stick diagram. If I draw the stick diagram for the CMOS inverter, the CMOS inverter stick diagram, how you can draw? This is my VDD, this is my VSS, this is my VSS, and this is my demarcation line. So the transistors are represented like symbol plus symbol. This is a PMOS above the demarcation line. Below the demarcation line, this is nothing but a NMOS. Above is PMOS, below is NMOS. Now I can label this as the transistor terminals. Like this, I'm going to label as a gate. This I'm going to label as a drain, a source, and this is nothing but a drain. Similarly, this NMOS, I'm going to label this as a gate, source, and drain. This plus symbol indicates here it is nothing but a PMOS and NMOS. So how you can connect this the stick diagram? How to draw the stick diagram? This is nothing, but you can see the source of my PMOS is connecting to the VDD line. So this is connecting to the metal. So this source is connecting to the VDD, and this gate and gate is connected. This gate and gate, the gate is made up of polysilicon. This is connected. Gate and gate is started both PMOS and NMOS, and then this gate and gate is started is connecting to the input to the metal. This is a V in, and then this drain and drain are started. Drain and drain started. This is connecting to the V out. So this is stick diagram of the inverter. So we need one PMOS and one NMOS. Source is connecting to VDD. Again, this source is connecting to the VSS. This source is connecting to the VSS. This is what I'm transforming my sticker diagram into the what? Schematic to the what? Sticker diagram. Transforming the schematic diagram to the sticker diagram. Now, actually, what is a layout is nothing but when you know how to draw the sticker diagram for any schematic. So layout is nothing but the standard dimension. Layout is nothing but the standard dimension. This is nothing but a sticker diagram. Sticker diagram with what? Standard dimension. Means dimension. This is nothing but a layout. So in this course, we will be talking about how to capture the schematic. Once you capture the schematic, how you can do the pre-simulation. The steps are like the flow of this layout, designing any analog based integrated circuit. The flow goes like this. Start with the schematic. So do the schematic creation. So once you create a schematic creation, do the pre-simulation. The pre-simulation is basically done with the prime wave. The tools which are using to do this is nothing but prime wave. This is what, let me show you. So start with the schematic creations. Once you create the schematic, do the pre-layout simulation using prime wave design involvement. Once you do this pre-layout simulation, again we'll go for the layout. In the layout, we'll do how to do the routing, how to do schematic layout editing, how to do the auto routing, topology routing, pattern routing, interactive routing, how to interconnection of the layers. This is done at the layout section. So once you draw the layout, we will be working with DRC rules. So DRC means it is a design rule set. This design rule check will be depending upon the foundry. So different nanometer technology work with the different DRC rules. So that is provided by the foundry. So based upon that, different node which you are working on, different channel length which you are working on. So you have to verify your layout with DRC checks. DRC checks, and you will do LVS checks, design rule check, LVS check, and other checks we will do. And then after doing the checks, we'll do the parasitic extraction checks, LPE checks. So at the time of layout, the other checks we are doing is nothing but like in design error checks we'll do. So like DRD error, DRC error, VR checks, what is the metal density analysis, color decomposition, and then some electrical checks we'll do like electromigration, resistance check, capacitance check, shielding coverage checks, and then some power device design checks we'll do at the time of the after drawing the layout. So once you draw the layout, so we will be doing the DRC and LVS. Then after doing the DRC and LVS checks, we'll do the parasitic extraction. Then again we'll do the post layout simulation. to comparing the operation of your schematic after drawing the layout to comparing with the pre-layout simulation. So we'll do the post-layout and then we'll do checks like reliability checks, static resistance check, EMIR analysis check, and electric rule checks we'll do after drawing the layout. So if you see this, the entire flow of layout, this part of engineers in the layout section, we call it as a design engineer. Design engineer. And this part of section is done by layout engineer. Layout engineer. And basically this part of section we can also call it a post layout engineer. Sometimes this is also done by the design engineers also. Design engineer. So in our course, mainly we'll focus on this, the custom layout to design. So we'll focus on this. Given schematic after do the pre-simulation, we'll understand that how to draw the layout for the schematics. Layout draw the schematics. So mainly we'll focus on how to do DRC checks and the LVS checks. And then we'll see that how we can extract in the parasitic extraction like resistance and the capacitance checks. So for this flow, I think I've already mentioned what are the tools we are using for this is to capturing the schematic, we'll be using the custom compiler, and then to do the pre-layer simulation, we'll be using PrimeView. We'll be using the PrimeView, and to draw the layout, again we'll be using the custom compiler, and then to check the LVS and DRC, we'll be using the tools called as IC validated, and to do parasitic extraction, so we'll be using the star RC, and then again to do post-layered simulation, we'll be using the PrimeView environment. Like many other spice tools are available. After that, we are using the PrimeView from the Synopsys. And for this other checks, we need other tools, basically which we are not discussing this. This makes more cost to do all these checks. That tool wise, it cost more. So that we'll not doing all these checks. Mainly we'll focus on how to draw the layout and then how to check the DRC and the LVS checks. So this is what the entire flow to design any integrated analog integrated circuit. The flow is start from like this. So start with the schematic creation, do the pre-layout simulation, then draw the layout, and then do the verification like DRC and LVS, other verifications. Then do the post-layout simulation. So in this course, especially, we'll more focusing on this this part. This part. So even though we will teach you that some of the analog circuits like level shifters, Smith trigger, then single stage open, double stage, two-stage opens, and some of the PLL circuits, PLL block, and then voltage control oscillators. We will be showing you that how to capture the schematic and then how to do the pre-simulation. So once we're done with the pre-simulation, we are going to draw the layout for the given analog schematic. So with this brief introduction, you can see, as I mentioned that this is for 6 months training course. I said the 2 months basically will covering the basics like digital system design, and then we talked about CMOS, semiconductor metal oxide fundamentals. Then we'll talk about TICL programming, then Linux part. In the advanced part, basically we'll go with this network theory, and then we'll start with what are the layout issues, what are the different layout issues, and then we'll talk about how to do the prevention of the layout issues. So in this course, the syllabus, what are the circuits we'll be going through is okay. Let me go through this. Already I have shown that if you look at the layout in ASCII design flow, this is what entire ASCII design flow, as I said. So we'll start with the idea of concept. Once you have an idea, we start defining the design, means schematic development, schematic capturing. Once you do the schematic capturing, then implementation, then do the pre-simulation. Any changes, means comparison with the design specification, according to the design specification, we'll do redesign. This part basically is nothing but a design part, electrical design part. So once you done with the design part, then we go for the implementation, drawing the layout to the given schematic, like physical implementation means layout. So after the drawing the layout, we'll do various verification as I mentioned. We'll do DRC, ERC, LVS, and then antenna checks, then parasitic extraction. So after that, we'll do the post layout simulation. Then this is giving in the form of GDS2 file. Where GDS is nothing but graphical data stream file. So that contains the information about the layout, the geometrical shape of the layout information in the binary format. The GDS tool will be understanding by the fab foundry. Foundry can understand only the GDS2. So once you draw the layout, converting, making this as a GDS2 file, so that is giving to the fabrication foundry. The foundry is going to design the product, make the chip, and then releasing to this product is releasing to the market. This was the entire analog design flow. Analog design flow. So if you talk about the layout, what is the important of the layout is layout. There are many engineers are comes in the layout. We call analog layout engineer, then the radio frequency layout engineer, and digital layout engineer, and then input output layout engineer, and standard cell layout engineer, and mixed mode signal engineer, and then memory layout engineer. So this is what you can become a expertise in the layout to the other layout. Then you can expertise in the different layout engineer. Okay, and if you look at the syllabus, what we are going to cover is nothing but basically this is what we are going to cover. So we will be covering the entire CMOS foundation, and then we'll understand in CMOS what are the secondary order effect of the CMOS, and we'll understand different types of the layouts and their differences. As I mentioned, analog layout engineer, digital and analog and mixed mode layout engineer, memory layout engineer, and then circuits which we are going to do in this course is nothing but some of the analog circuits and mixed mode circuits we're going to discuss. So analog circuits like we'll do level shifter, current mirror circuits, Smith trigger, operational amplifier. So operational amplifier with single stage, dual stage we'll do, and low drop voltage regulators. We'll discuss about band gap reference, then PLL phase lock loops, and then we'll talk about serializer and deserializer. Then we'll also talk about some of the converters, the converters like analog to digital converters and the digital to analog converters. These are what different circuit we'll be going through in this course. So we'll draw the schematic and do the pre-layout simulation, then draw the layout and do the physical verification like DRC checks and LVS checks. Yeah, I think this all about what are the topics we'll be covering in the basics and then advanced part. Like in CMOS, we'll be talking about complete CMOS, and then semiconductor property, and then MOSFET, different types of MOSFET, its operation we'll be discussing. And device physics, we'll talk about some of the basic semiconductor devices like diodes, PN junction diodes, bipolar transistors, and then MOSFET. And then we'll talk about fabrication process, and then we'll understand that how to draw the stick diagram for the given schematic, and then schematic drawing and the pre-layout simulation. And this is what the layout plan for the given schematic. And so this is one example where you can see that this is a layout of your voltage control oscillators. So this is what these are the circuits you are going to develop in the layout course. Okay, just I'm giving the example like how you can look voltage control oscillators. So let me show you that a few layouts which are we developed. So I said that what is the tool we are using for this is nothing but custom compiler to draw the layout. So you can see, let me go with the circuits. Like let us go with the inverter. Okay, let me go with some unlock circuits. An unlock circuit I'm taking as a level shifter. This was the schematic of the level shifter. So we'll be teaching you that basically how you can draw the layout to this. You see, this is a layout. This is a layout of level shifter. So made up of three CMOS. This is a one CMOS, and this is a two PMOS and two NMOS. Will make you to understanding that how to do routing. Okay, how to do placements, routing, how to draw the different metals, what are the properties of the different metals. We will be teaching you, and even in free simulation. So let me go through this. For free simulation, also we'll teach the circuits like PLL, converters, then single stage op amp, dual stage op amps. Some of the circuits like source followers, current mirror circuits. I think this is not working. Maybe server busy. That's not. The circuits like some of the circuits will be teaching you that how to do the pre-simulation. Like so you can see, this is one of the circuit for uh, phase frequency detector circuit it is. We will show you that how to draw these circuits and do the pre-simulation. So this is one block of your PLL. So like that, we will be teaching you all the schematic which you are using for bigger blocks like PLL and then analog to digital converters. We will be teaching you how to draw the schematic and do the pre-layout simulation and then do the layouts. So this is what the complete what are the circuits we'll be talking about in the analog layout part. So from your side, if you have any questions out there, you can kindly go ahead. So any other sort of questions from your side, can you please go ahead? So also I said that we'll be talking about some of the layout dependent effects like a latcher problem or antenna effect when you're drawing the layouts, and then well proximity effects, length of diffusion, then how to check with IR drops. Some of the layout dependent effects means layout issues we'll be discussing, and then also we'll discuss about how we can do the prevention to this. Prevention to this, we will be discussing. Yeah, this is what the flow of analog layout engineer. So what he is going to start, from where he is going to start, and where he is going to end. This is what the entire flow. So this picture basically, which will tell you that what layout engineer is going to do. This is what complete analog design flow. Yeah. So anybody from your side, any questions are there? Can you please go ahead? Yeah. Hello.
How?
Yes. Hello.
How this Linux is related to this? It's like your hello.
Yeah. Yeah. You're audible. Hello. Basically,
Yeah, how
Linux
this Linux?
commands. Yeah, basically Linux commands are used to work with any. See, all your layout-based tools are working on Linux-based platform, where you should know that Linux commands to launching the tool. Suppose this is where I can launch the tool. So this is what I'm using CentOS operating system. The CentOS operating system. I said that layout tools are work on a platform of Linux. Suppose I want to launch this custom compiler tool. I should be having idea about the Linux commands. So here I am using some Linux commands like by default it is a Bonnie again shell. Now I need to change this shell into the CH shell. So this is a command I'm using. After doing that, I want to source the root configuration file, chrc root configuration file. I'm sourcing this. Then I'm using this command to launch the custom compile. So where Linux commands are help us to work with the Linux operating system. So for this, so we'll be studying the Linux commands. I hope you got an point. So why basically you need to study the Linux commands? Because many of
Yes, sir.
VLSI tools are working on Linux platform. That's why you need to go through the Linux commands.
Is this installable or you will give the remote access?
Okay, let me talk about the tool access. So tool access, we will be providing you the remote access. How tools are giving to you is nothing but so we'll be providing the tool credentials. Like we'll be working on 40 client VPN. So we'll be providing you the credentials, username, password. We'll generate and we'll giving to you. So you can work remotely. Okay. Tool access will be provided for 24/7. You can see once you enroll, they'll create the 40 client VPN and then they will provide the username password and even they will share what IP address you're working on and then using putty username and password they will share. All the tool related things they will be providing after enrolling and then they will also teach you that how you can configure all this putty client VPN configuration, putty configuration, then VNC configuration, VNC configuration. Then also they will teach you that how to invoke the tool in Linux operating system. You can do remote access. The tools can be given for the remote access. I hope you got an point, right? So we will
Yes, sir.
provide you all the remote access credentials. Yeah. Any other questions from others? Can you please? You can go ahead. Maybe any doubts are there. Basically, if you talk about this course, each course completion, we will be doing the test. So once you go through this, basic part, like suppose you're done with the digital system design, how basically evaluation process is done to select your resume and giving to this to the client, we will be doing the test. Okay, suppose you're done with the digital system design, we'll be conducting the test and we'll be connecting your presentation and we'll ask you to prepare the 10 to 15 slides and the topic which you like, the digital system design. We'll ask you to do the presentation to check your presentation skills. And then we'll be conducting the mock interviews for each course. Each course, student has to secure at least 80% of the marks in each course. And then this marks will be basically they are evaluating at the time of the job support. At the time of job support, they will check the performance of all the tests and you should meet at least 80%. And then they will select your resume and sharing to the recruiters after completion of the course. Okay, and then if it is coming to the attendance, attendance percentage is 80% attendance is mandatory. Attendance, whether you are attending offline session or online session, 80% of attendance is mandatory. So all this they will check at the end of the course when they start doing the job support. Yeah. So this is what the complete overview of layout. From your side, if you have any questions are there, you can please go ahead. If no questions, we'll wind up the session here.
Hello.
Yeah, Tanisha. Yeah, hello.
So when we'll be
Yes.
having the access to the tools?
Basically, you don't need any tool from the server. You don't need any tool access for the basics. Okay, basics you don't need a tool access. So when you move into the advanced part layout, where you are working with the custom compiler from the Synopsys, at the time of advanced layout session starts, they will be providing you the tool access. Okay, so after
Okay, sir.
your 2 weeks or 3 weeks, they will provide the tool access.
Okay, sir.
Okay, basically for this digital system design, you don't need any tool. And then GVM editor, they will teach you that how you can install the GVM editor for Windows, iOS, or a Mac operating system, how to work with this GVM editor. And preferably for Linux commands and then tool command language, TCL. So they will be using you, they'll be teaching you the Sigwin simulator. The Sigwin is a kind of simulator where you can feel Windows has a Linux operating system. They will teach you that how to do installation of the Sigwin and how to work with the Linux commands, then how to run the TCL programs. TCL program. When you are coming to the layout, advanced part of the layout, then they will provide the VPN access, where you can use the custom compiler, other tools as I mentioned like PrimeView, IC Validator, StarRC. These tools they're providing once you start with the advanced part of the layout.
Okay, sir.
Yeah. So any questions from the others? Can you kindly go ahead?
Hello, sir.
Yeah, yeah, Yogita.
Hello.
Yes.
Sir, for which
Yes.
technology we will get the hands on?
Uh, yeah, yeah. So sorry to that. I have not mentioned it. So
Yeah.
basically, we have some run set file for 40 nanometer. The 40 nanometer, basically, we'll be teaching you that how to do the pre-simulation. Pre-simulation is done in the 40 nanometer. It is irrespective of any nanometer, no problem for the pre-simulation. So we'll be using the 40 nanometer for schematic capturing, schematic capture, and then pre-simulation, pre-simulation and schematic capturing. So for drawing the layouts, we'll be using 28 nanometer. 28 nanometer PDK we are using. Process design kit we are using for 28 nanometer. All the layouts will be doing with the 28 nanometer, and the pre-simulation basically will be working with the 40 nanometer. Here, did you understand? 40
Yes.
nanometer PDK we are using. 40 nanometer PDK for pre-simulation and 28 nanometer for drawing the layouts. Yeah. So any other questions are there? Can you go ahead?
Hello.
Yeah,
Hello.
Abhishek. Yeah, Abhishek. Yes, Abhishek.
If someone misses any classes because I am working professional, so
Hmm.
will it be provided recording for that missed classes or anything like that?
Oh, okay. Let us talk about mode of the classes. Mode of the
Yes, sir.
classes. Okay. Basically, we have three modes. Three modes of the classes we have. So, what is the first mode is nothing but weekdays. Weekdays batch. In weekdays batch, we'll be taking from Monday to Saturday. So first we'll be teaching you the theoretical aspects and followed by the lab session. Morning we'll be having the theory sessions. Afternoon we'll be having the lab sessions in weekdays. And second mode of the classes it should be weekends. In the weekend we'll be doing on Saturdays and Sundays. Saturday and Sunday. So Saturday, Sunday we'll be covering the theory as well as the lab. But comparatively, weekend batch the size once will greater than your weekdays batch. Okay, this is second mode. And then third mode is e-learning, e-learning mode, where we are providing the recorded sessions for all these schematic and layouts. So from your end, you should practice this, going through these recorded sessions. And any questions or any doubts are there, we'll be creating the WhatsApp group. In that WhatsApp group, you can post the query. So any support sessions are required for the e-learning. So we'll be arranging you on Saturdays and Sundays. Saturdays
Sir,
and Sundays. You know.
sir, sir, will
Mm.
the content of e-learning mode and the other two modes will be same, or there will be variation in
Yeah,
the
yeah.
contents of e-learning?
Yeah. Same content. What are the contents for weekdays and weekends? We'll be providing the same content. So each day
That will be
when the
recorded.
session is happened, yeah, each day when session is happened, we'll be doing the recording of that. And that recorded session will be available for each day after 7:30 p.m. So we have a platform like InSkill platform. So we'll be providing you the username and password in Skill platform where you can see that today session is happened. That session recorded session is available after 7:30 p.m. in your InSkill platform. Okay. Whatever the sessions we are doing, all the sessions will be recorded and that is provided to the student for the later part if they want to revise. So they will be providing that. So this will be for both weekend and the weekdays batch. All the sessions will be recorded and provided in recorded videos. Yeah. So any other questions from Abhishek?
Sir, currently I am I'm in MTech graduate from NIT Allahabad. In July, I have completed my MTech. So will it hamper placement because there will be some gap while doing the training of analog layout course. So
Somewhere
I
your
mean, will I
voice
get
was
any trouble?
no. There was a lot of background noise. Can you repeat again?
Sir, just now in July, I completed my master's from NIT Allahabad, and my domain is power
Okay.
electronics.
Uh,
So there will be some gap in doing these analog layout courses. So will I get any trouble in
hmm.
getting placement?
Yeah.
Right
Regarding
now, I am
placement
working
support.
in,
Hmm.
I mean, sir, just now I am graduated in MTech. I mean, MTech from NIT Allahabad. Right now, I am working in, as a project engineer in IIT Kanpur. So, I mean, if there will be any gap after MTech, will it hamper my placement?
Yeah. Obviously, you'll get an placement. But the thing is that uh, regarding this, suppose you see you're long back, you're done your course, and then you work with some other area, and you want to switch it to the custom layout engineer. Obviously, this is it is okay. But until and unless, if you look at the package wise, uh, you have to go with the fresher one. Suppose you are switching the domain, if you want to become a custom layout engineer, you should go with the fresher one.
No, right now,
Regarding
sir, I'm
Hmm.
hello. Right now, I am
Yeah.
working in power management domain, that is in analog circuits only. And
Okay.
uh,
Hmm.
so domain is something like same. I have worked lot of things in analog circuit. I have also done lot
Okay.
of projects, but I did not got any opportunity. So that's why I am
Okay.
looking for this course. So my domain
Uh-huh.
is also related to analog electronics. So
Yeah, yeah. So in such case, okay, you can add that whatever the work you have done in your resume. I think regarding the experience, I think for the career gap, you need any added experience. You should talk to the admin. I have less idea about that. Suppose you are seeking any experience from the institute side, you should talk to the admin regarding that. But obviously, coming to the placement, so until you get placed, there is a support is available from the institute. Do you need any support for the placement? Do you need any support for sessions? Until you get placed, there is a support is provided from the institute. Okay.
okay, sir.
Yeah. Any other questions? Can you please go ahead? Okay. Any other questions? If you have, you can please contact us. So with this, I'm going to wind up the session. Thank you all.
Thank you,
Thank you,
sir.
sir.